Hello everyone. Welcome to this session on software design patterns. I am Oluwatobi and I will be taking you through a series of lectures and practical demonstrations of software design patterns. Software design patterns enable you to build robust, scalable, performant, and easy to maintain solutions. Every software engineer should know at least most of these patterns to enable you to just design software in a very scalable way. Um, the software design patterns will be covering divided into three parts. So the creational patterns, structural patterns, and behavioral patterns. And then I decided to throw in enterprise patterns there also. Today we'll be covering the factory method design pattern. So just so you know, there will be code demonstration in this session. So, but I just wanted to cover some theory so that we have a good understanding of why we would employ a software design pattern. So the first thing you need to do is to understand a problem you need to solve, the problem you are solving, and what pattern fits the problem. So going into that, we look at the problem. So let's say you want to review a naive reporting system. So you're building a reporting system for your company. Your boss says, "Hey, we need PDF reports." So simple enough. You write the code, and then next week he says, "Oh, okay, now we need Excel reports." So we had PDF reports, now Excel reports, and then you put an if-else statement there, and then you have your Excel reports. And a month later, your boss says, "Ah, now we need HTML reports." So you throw in that also add another else statement, and then you have your HTML reports. And then your code is having your code is really conditional, and meaning that every new report type means modifying existing working code. Um, there is a better way to do that, and that's the factory method pattern. So let's review what that code looks like quickly in the IDE, right? So I just exit my slideshow here, and then I'll go to the IDE right here. So this is what your um, code looks like right now. You've added a PDF report, Excel report, HTML report. So, and just imagine that you have a lot of logic for each of the reports, so 50 lines of code. So this is huge. And then when you need XML reports, you need to come modify this class. So what's the problem here? This violates open close principle. You must modify the existing code to add new features. It's tight coupling. This class, which is your client, knows about every report type. So this client class is tightly coupled to every report type, right? And then it's hard to test. You can't test PDF generation without this class. If you're going to test PDF generation, you're going to use this class. The code is brittle. One wrong change in the PDF section could break Excel reports. So we need to be able to design. We need a design that lets us add new reports without touching existing code, and that's where the factory pattern solution comes in. So back to our slideshow. Let's define it. So the factory method defines an interface for creating an object, but lets subclasses decide which class to instantiate. It lets a class defer instantiation to subclasses. What does all this mean? So defines an interface for creating an object. So what that means is that we create a blueprint for object creation. It lets subclasses decide. So each report type decides how to create itself, and then it defers instantiations to subclasses. The main class doesn't create objects directly. So basically the idea is that the factory method allows you to delegate object instantiation to you know um, away from the client. The client does not know anything about object instantiation. The intent is to encapsulate object creation, right? Is to abstract out the object creation. Instead of using new keyword directly in your business logic, you delegate creation to specialized factory classes. So let's review the components. What makes up a factory method? When you're writing out your factory method, these are the components that are involved. You have a product. So a product is an abstract class or interface to products to be created. So the factory method creates, um, objects, right? And then those objects will have classes. So that's the product, right? So but then you have to define an abstract class for your product, and then following that, you define a concrete product. The concrete product is the implementation of the product interface or abstract class. These are the real products. And then number three, you have a creator. So this now is the factory. You have an abstract class on interface with the factory method for creating products. And then four, you have your concrete creator. It's a class that implements the factory method of the creator to create a concrete product. So you have your concrete product, creator, and concrete creator. So the products is and the concrete product, right? They are connected, and eventually what you want is something to create your concrete product, right? This will all make sense when we start looking at UMLs and the code. So let me move to the UML diagram now. All right, going to UML. Yes, so I'm starting off with you know the product, right? So this interface represents our products, and first you start with an interface, right? Because um, as with all software design patterns, you want to depend on abstractions and not implementation. So you define an interface, iProduct, and then you have your implementations and implement the iProduct. So here is concrete product A, concrete product B. So this is your I report, and then this is your PDF or Excel reports, for example. And then you define an interface for your creator. So your creator now has a method that creates a type of iProduct. So any of these types, right? And then you define your concrete creator that is responsible for creating a concrete product. So as you can see here, a concrete creator implements the creator, and it then is able to create a concrete product A or a concrete product B. To help this make more sense, take a look at this. So we have our I report. We define an interface for an I report, right? And then we implement the interface for PDF report and an Excel report. So this is just OOP, right? Using polymorphism and inheritance. So you see that PDF report implements the I report and as well as the Excel report. And then you have something like a report generator. So this is our creator here. And then you have a PDF report generator and an Excel generator. These implement the report generator interface. And as you can see, the PDF reports, would create a PDF report, an Excel report generator will create an Excel report. So with this, we have defined a factory, right? Our factory is the abstract factory is this, and then the PDF report generator and Excel report generator are the concrete factories. Now, our client does not know anything about all that's going on down here. All your client knows is about the factory, the creator interface. And your client will use this creator interface to create whatever product it desires, right? So you have your client is loosely coupled to how products are created. So let's take a look at code now, so all this will all make sense. So this is our problem. This is where we are going from. We're going from this, which would be big and gigantic and messy, and going into the solution here. So starting, let me just close all of this, right, so that we have clarity from the top. So looking at the comments here, right, the factory components, you have your products and a concrete product A, concrete product B. So your product, again, it's an abstract class on interface. So in our example, it's our I report here, and then our I report just defines everything a report should do. A report should be able to generate a report, save a report, get the format for a report. So it's just an interface, right? Defines the signatures, and then after we define our interface for our product, we have a first product, which is a PDF report. So this is our first product here, the PDF report, and then it implements the signatures for the I report. So as you can see here, it has implemented the three signatures. Next, we have our next product, the Excel reports, and it also implements its own, methods, right, from the I report. And we can go on and on like that. For HTML report also, it implements the I report here, right? So And then once we're done with our products, right, we then, define the abstract class or interface, if you will, for our factory method. So this is very important. Pay attention here. The abstract class for the report factory, you know, has a method. This is what is called the factory method, and its job is to create reports. So it returns an I report, right? Which is the interface here, and this makes our code very loosely coupled, because then we are returning an I report, and this is also an abstract you know cl class. And then once we're done with that, we have our concrete creators. So for the PDF report factory, we implement the report factory. And the job of the PDF report factory is just simple. It returns a new PDF report. So it returns this. The PDF report factory overrides, the method signature here, and then does its own implementation. And then the Excel report does the same thing. It creates Excel reports, right? It overrides the factory method and returns a new Excel report, which is a type of I report. Same for the HTML report factory. We override this and then return a new HTML report, which is an I report. And I have a generic report factory here that I would explain later, just to show you different ways of implementing the factory method. But once we're done with all that, we have our factory. And to show you that this works, I have I have tests, right? So tests here, our factory method tests here. So here in this my test, in the arrange section, I have created factories, and then for each of the factory, I can create a report, and then assert that the reports are of the set of the right type. So as you can see, PDF report is of type PDF report, HTML report is of type HTML report, and then call one of the methods and asserts that it's returning the right thing. So the test pass. Okay, I'm looking for a way to run the tests. So we can see the test pass once I run it here. The tests pass, yes, I can see it in Visual Studio here. Now to demonstrate this from a client, let's go to our client up here. I have a console client to test this out. So if I go to the factory method demo, right, I have this method. Just you could focus on this method. And what this method does is it's gets a report factory, right? It gets a report factory, and then after getting a report factory, it then creates a report, right? But um, what we are assuming that the user wants to do here is the user is going to select the report type they want, to generate and save, right? So if I run my console client here, it's going to ask me to select the report type. And these are the kind of problems that factory method is suited for solving, right? When you don't know at runtime, the objects that your application would use, right? The objects that your application would create, then you should be thinking about a factory method. So at runtime, we don't know what type of report our user would want, but then we give them an option to select. And if I say, hey, I want PDF reports and press enter, then a PDF report is created. If I say I want an HTML report, then an HTML report is created, right? If I say I want an Excel report, an Excel report is created, and on and on. If my boss comes tomorrow and says, hey, we need XML report now, right? I wouldn't touch my client. My client is agnostic. I would just I'll move on to um, I'll go into the patterns here, and then I will just I'll come here and say, hey, we need XML reports. So I'll come here, I'll define a class, for XML reports, which is going to just implement its own implementation, right? So I'll just say public, class XML reports. Yeah, and then all this is generated. I'm using GitHub Copilot, so it helps me generate all of this. And then I have my XML report. And then once I do that, I can come here and create an XML report factory, and then it will be ready. So that brings me to how to show you this another way of designing your factories. So you could have individual factories like this: PDF report, Excel report, HTML report, or you can have one generic report factory that's responsible for creating your products. So here I need XML report, so I'll say XML, and then it's going to generate XML report for me. So what this means is that all I have to do is to you know modify this, and that's all. My application will just work. My client does not need to know about the reports, does not need to know about what's going on here. This is just added to it, and it makes my code very easy to maintain. So I don't modify any of the existing classes, right? So I'm conforming with the open close principle. Also with the single responsibility principle, right? So this is XML report. It has nothing to do with any of the reports here. So let's go to when you would need this type of when the factoring method is needed, right? So when to use the factoring method? When you don't know what the exact types your code will need, like the reporting system, you don't know the exact types that your code will need at runtime, right? So you should think about using the factory method, right? When you want to provide extension points in your library or framework, so think about if you are writing a library or framework and you're going to give this to another team or an external team, and you want them to be able to extend your code, right? You should think about using this factory method. If you're tired of giant if else statements for object creation, if the user selects this, then this, you should use the factory method. Or you want to reuse existing objects. So you avoid when so it's not always suited for every situation. When you only have one product type, if we're only gonna be creating only one report type, we don't need a factory. If your objects are simple, if the pattern will add accidental complexity, or you already have a DI that handles simple object creation. So if your use case is very simple, you don't you know the exact types that your code would create at runtime, you don't need a factory method for that. So you should avoid it at that time. Pros and cons: single responsibility, creation code is separate from business logic. That's a big plus. These are the things that make our code very easy to maintain. Open closed principle is followed, so new products equals new factories, or extending existing ones. No code existing code changes. Loose coupling, client code depends on interface, not concrete classes, right? So your client code does not know anything about your concrete classes. Consistent construction, all objects created through standardized processes. And then flexible implementation, can have one factory for all products or separate factories per product. The cons, so there are some cons you need to be aware of. Potential for proliferation, can increase number of classes if you create separate factories for every product, and that's why I showed you the other method. So you don't have to have a factory per product. You can just have one factory that creates all your products. Not always necessary. Sometimes a simple new constructor is enough, right? And then learning curves, your team members need to understand the pattern. So those are the pros and cons, but factory method is always great. So it just depends on your use case. It's like everything software design and architecture. It depends, right? You have to really factor understand the business problem, and then you apply it. So I have this challenge for you. If you have come this far, thank you for watching. Like and subscribe to the channel. It really helps to support this series I'm doing. So you could build a payment processing system that handles credit card payments, PayPal payments, cryptocurrency payments. So just imagine that your users have to choose either of these payments, when they are visiting your solution, and then every payment will have its own validation rules, has its own processing logic, and then hey, next week you should be able to probably add Apple Pay next month without changing existing code. So you could just demonstrate this using the factory method. I would leave the link to the code and the repository in the description, and I will see you next time. Thank you for watching, and happy coding.